Hey everyone, this is your host bringing you breaking developments on one of the strangest objects ever to enter our solar system, Interstellar Object 3I Atlas. And today's story is not just big, it's electrifying, because 3I Atlas has now become the direct target of a fast-moving solar coronal mass ejection, a CME, heading straight toward it. And what's even more surprising is the quiet conversation happening behind the scenes among researchers, astronomers, and geophysicists who are trying to make sense of what this thing is actually doing. Before we get into all of that, do me a favor. If you're watching this and you haven't subscribed yet, make sure you hit that button right now. You don't want to miss the next 48 hours because what happens next could completely change the conversation around this object. Okay, now let's get into it. For weeks, the astronomy community has been locked on 3I Atlas, as images began coming in from amateur telescopes, backyard observatories, and eventually major space instruments. And things were interesting enough even before this latest development. But now, with a CME locked on course toward 3I Atlas, the energy around this event just exploded. So here's what happened. Earlier today, one of the active sunspot groups that has already been responsible for major geomagnetic events recently erupted again. It launched a coronal mass ejection, basically a massive burst of charged particles and magnetic energy into space. Not the biggest eruption ever, but big enough and based on multiple solar weather models that CME is now headed directly toward 3I Atlas. If the timing holds, the impact should happen around November 22nd, roughly 1200 UTC. That's the predicted moment when this wave of solar plasma sweeps across the region of space where 3I Atlas is traveling. Space weather models aren't perfect. Observing the trajectory on space, weather models shows a direct path aimed at this interstellar visitor, slightly above the ecliptic plane where 3I Atlas is currently traveling. If this prediction holds, we could witness a rare cosmic interaction, a CME colliding with a fast-moving interstellar object as it moves through our solar system. Understanding what this might mean requires a closer look at 3I Atlas itself. Over the past few weeks, astronomers have observed the object's coma, the cloud of gas and dust surrounding its nucleus, beginning to expand dramatically. It now displays a diffuse coma, stretching across hundreds of thousands of kilometers, and, for the first time, the emergence of a tail and visible jets. This is a stark contrast to observations from just 2 or 3 weeks ago, when the object seemed far more subdued. The difference is not just visual, it is a signal that 3I Atlas is responding dynamically to the environment around it, including solar radiation, gravitational influences, and now, potentially, an inbound CME. The upcoming NASA images are expected to clarify these changes, helping us understand the object's mass, nucleus size, and outgassing behavior in ways that were impossible before. Observers on Earth are preparing as well. Amateur astronomers across the globe are calibrating their telescopes and refining their imaging techniques. High-resolution, stacked long-exposure photos are essential to truly capture the object's tail and jet features. The scientific stakes are high. Accurate measurements of the nucleus size, tail length, and jet dynamics will allow astronomers to estimate the object's mass loss, non-gravitational acceleration, and overall activity. Previous Hubble estimates suggested a nucleus up to 2.8 kilometers, but other analyses have suggested it could be as large as 50 kilometers, highlighting the uncertainty and the need for more precise data. NASA's livestream could finally refine these numbers, giving us a clearer picture of what this interstellar visitor truly is. So, as we count down to November 19th, the world is bracing for a unique moment in space observation. The live stream promises high-resolution images, detailed analysis, and perhaps the first glimpse of how an interstellar object reacts to a solar storm. In real time, I encourage everyone watching to register for alerts and subscribe to my channel now so you can follow the unfolding story live. This is more than just comet watching. It is a front-row seat to cosmic drama, a chance to witness science in action, and an opportunity to see the universe reveal its secrets, one solar particle at a time. In the coming days, we will track the CME's progress, observe 3i Atlas' response, and analyze images as they are released. The stage is set for an astronomical spectacle that combines mystery, science, and the raw forces of the sun. For now, we watch, we prepare, and we wait. The interstellar traveler is moving, the solar storm is approaching, and soon humanity will witness what happens when the two collide. As we turn our eyes back to 3i Atlas, it becomes clear that this interstellar visitor is far from ordinary. What we are witnessing is not just a comet passing through our solar system, it is an object alive with energy, reacting to forces that are both visible and invisible to the naked eye. The incoming coronal mass ejection is only part of the story. The real drama lies in the complex plasma environment surrounding 3i Atlas, a delicate dance of charged particles, magnetic fields, and ionized dust that behaves in ways that challenge even the most seasoned astronomers. The coma of 3i Atlas is staggering in scale. At times, it stretches across 700,000 kilometers, roughly half the diameter of the Sun. It is composed of gas, dust, and plasma, all interacting under the influence of the Sun's radiation and magnetic forces. When a CME hits an object like this, it is not merely a visual spectacle, it can trigger dramatic physical changes. Observations from previous comet missions, like the Rosetta probe's encounter with Comet 67P, have shown that CMEs can amplify magnetic fields around a comet by an order of magnitude, sometimes spiking from a few tens of nanoteslas up to several hundred. For 3i Atlas, a CME impact could reshape the tail, energize jets, or even produce a temporary disconnection event. Despite being relatively small, with a nucleus estimated between 2.8 kilometers to possibly 50 kilometers, 3i Atlas demonstrates behavior that would seem improbable for an object of its size. Its rotation period is approximately 16 hours, slow enough that one might expect any gas jets or ejections to disperse chaotically. Yet, images captured over the past few weeks reveal remarkably stable, directed jets and a well-defined tail. How is this possible? The answer lies in the interplay of plasma physics and electromagnetic forces. The gas and dust emitted by the nucleus become ionized in the solar environment, forming charged particles that respond to magnetic fields. These fields can guide and confine the plasma into stable channels, producing the coherent jets we now observe. It's a process both elegant and violent, a cosmic ballet dictated by invisible forces. Amateur astronomers have been capturing this activity, though there are challenges. 3i Atlas is a dim object, far fainter than Venus or Jupiter in the night sky. To resolve its tail and jets, observers must use long exposure photography and then stack multiple images to increase the signal-to-noise ratio. Without this technique, the tail appears faint or even invisible, leading to confusion among viewers watching live feeds. The CME that is expected to impact 3i Atlas on November 22nd will put this system to the test. Space weather models show the CME trajectory aligning almost perfectly with the object's path, slightly above the ecliptic plane. If it hits as predicted, we may see the tail react violently, jets flare, and the coma brighten, offering scientists a rare opportunity to measure how interstellar material interacts with high-energy solar plasma. These observations could refine our understanding of mass loss rates, outgassing, and the electromagnetic environment around such objects. For an interstellar visitor traveling millions of kilometers through the void, this is an unprecedented experiment conducted entirely by the Sun itself. The timing of these events is fortuitous. 3i Atlas has recently moved past Earth's superior conjunction, providing a lateral view of its tail rather than a backlit perspective. This improved geometry allows telescopes on Earth, both professional and amateur, to capture features that were previously difficult to discern. Coupled with the CME impact, we may witness tail disconnections, plasma ejections, and variations in jet intensity, all in real time. Observers across the globe will be able to track changes and contribute to a growing database of imagery and measurements, helping to paint a complete picture of this extraordinary interstellar visitor. There is also the lingering question of what 3i Atlas truly is. While Hubble and other telescopes have classified it as a comet, its behavior is distinct from familiar solar system comets like Halley or even the Interstellar Visitor 2, I/Borisov. It possesses a diffuse, expansive coma, stable jets that resist dispersion, and an unusually large response to solar activity. Some scientists speculate it may be a remnant of an exoplanetary body or debris from a distant star system, adding to the mystery. Regardless of its origin, what is clear is that electromagnetic and plasma processes are shaping its appearance and behavior, and understanding these processes is crucial to interpreting the observations correctly. For viewers following along, this is a moment to act. As we anticipate the CME impact and NASA live stream of high-resolution imagery, I strongly encourage you to subscribe and enable notifications. You will not want to miss the live coverage, the detailed analysis, and the moment-by-moment updates, as 3i Atlas reacts to forces both familiar and alien. The coming days may reveal tail disconnections, sudden surges in brightness, or new jet formations that could challenge our assumptions about how interstellar objects behave. This is science unfolding in real time, and you can be part of it. In short, 3i Atlas is no ordinary object. Its slow rotation, enormous coma, and stable plasma-driven jets create an environment that is both delicate and volatile. The impending CME represents a natural experiment, one that will allow scientists to observe the interplay of solar plasma and interstellar material like never before. For astronomers, this is a chance to refine models, test theories, and observe firsthand how an interstellar object responds to extreme space weather. For the public, it is a reminder that our solar system is a dynamic, interconnected environment where objects from distant stars can interact with our sun in ways that are both dramatic and awe-inspiring. As the CME approaches and NASA prepares to release its images, the excitement is building. We stand on the edge of a cosmic spectacle, one that promises to teach us not only about 3i Atlas, but about the fundamental physics of interstellar travel, plasma interactions, and the delicate forces that govern the behavior of small bodies in space. This is a story that will unfold over the coming days, and as we watch, we gain a front-row seat to a mystery that is both ancient and immediate, distant yet astonishingly close.